Welcome to Project 16, and in this lesson I want to show you how to draw radial line developments. Now what that is we're going to take something that's round at a taper and we're going to be able to make a flat pattern out of this. Now it's really simple, it's not as hard as what it looks. There's a formula to it, and besides the formula the only other thing you need is this true length of this line right here. And then you'll have another true. See how it's got a flat spot here, and then it comes up another flat spot. So you'll have two true lengths of lines that you'll have to have for this, and this one, and then it'll have to come down to a point, that line. And I'll show you more about that. We'll actually do it here in just a second. Now the formula, and I'll open this up for you. The formula that you have is R divided by S times 360 degrees. That gets you your total angle here. Now the R stands for the radius of the outside, the largest piece, and then the S is your true length of your line. So with that said, let's go in here and draw it in AutoCAD. And basically how we start this off is I've already got your top and your front view here. Now of course this hidden line here is the main bottom, and of course this is the top of the cup. So what we have to do is we got to first figure out what the radius is of this, and it's radius of 3. Now remember our formula, radius of the biggest arc divided by S. Now S is the true length of this line right here. However, this one stops at this point. We got to figure this as a cone, and to do that, just take your line and we're going to extend to this line, there and there. You see this point right here? This is going to be your vertex at that point, and we'll go back and look at that again here. This point is going to be our vertex. So we got to find the true length of that line from this point to this point, and it's reading 8.5440. Alright, so now I'm just going to get the top of this, and I'll swing this thing across. And again, you're not really projecting anything to do this flat pattern. We need to go ahead and do the formula. So R, get our calculator. R is 3, so 3 divided by 8.544 equals 0.35 times 360 degrees. So we'll have an angle, in a complete angle, of 126.4. So what we're going to do is I want to put me a line right here, just straight up and down. Divided by 2, 63.2. Now what I've done is I took half of that, 63.2, and I want to set it up. 63.2, I've already got it set in polar tracking, so hit OK on that, hit my line, and basically all I want to do is come up here and hit 63.2, because it's going off, because 0 is right here the way I have it set. 63.2, and all thing I want to do now is I want to take and I want to mirror it to the other side. Alright, there we are. Now this is going away from us. What I want to do is take this and rotate it. Where this line right here is perfectly horizontal. And we can move this around and we'll set that up later. Now, so we've got the angle here. Now what I always do is take up here, and you remember how we done that in the last project. Move this one out of the way just a little bit. Get just that point right there. Come over, and what I want to do is I want to do an array on this. Grab this line, enter, grab the center point, and I want to have this thing go around 8 times. Just like that. Y'all see that? And of course this would be number 1, 2, 3, and everything would follow suit. You come down here to this point right there, you know, that would be 1. This would be 2 coming down them lines. So we've got to divide this thing up as 126.4 8 times. To do so, I'm just going to use my array again. Click on the line, catch the center point here, and then up here I want to change this to 8, and the fill pattern was 126.4. Now the problem of it is there's 8. See, there's 1, 2, 3, 4, 5, 6, 7, 8. However, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 spaces in between. Now look at this. 1, 2, 3, 4, 5, 6, 7. There are only 7 spaces in between. So you got to watch that. So actually there'd be 9 spaces. Just like that. So now this one right here would represent number 1. This one right here would represent number 2. This one represent number 3, and so on. Alright. Now you remember how I told you the most important thing to remember is to use this formula, be able to split this up evenly, the same amount that you did over here, and just number them. I didn't number them. But also know your true length of line. Alright, from the vertex up to the top is 8.5440. So what I do on that is I can go and get me a center point radius, click it right here, and do me an 8.5440, enter. And I'm going to trim. And again, you can't trim until you actually explode. You got to explode that array. Now you can go in there and trim. Alright. So at this point, looks like a turkey fan. I want to move from the main quadrant. I want to move it to this point. Bring it straight across. We got it lined up now. Again, really it doesn't make much difference when you line this up as flat pattern. So now we've got this in here, and that should actually fold up nicely to make our part. And again, it probably wouldn't have been a bad idea to have checked my angular dimension here. And it's saying 126. If I went in there to annotate and then went to my dimension styles, I'm sure probably just don't have my precision set. And it's perfect, 126.4. It's good to check that before we go too far into it. Now, the next phase you got to do is take you a aligned dimension from the vertex up to this point. You're getting 4.272. Again, grab this and just type it in, 4.272, enter. And basically this is how this is going to turn out. Just do you a trim, clean all that up, clean that up, and then this has got a bottom to it, so hit your center radius, and I'd put it right in the center of it, and we'll move it. This is actually going to be a radius of 1.5, enter. Just hit move, grab that object and bring it down to the center. Now when you print this out, it looks like a coffee cup. This right here will be the outer part. This will all enclose on top of this circle. And just a real quick trick to check yourself, when I click on this arc, it should have the same arc length as this radius right here does. So click on this, we'll check the properties of it real quick. Arc length's 9.4244. We'll check this. Let's check its arc length. 9.4248. So right there shows you real quick everything should be perfectly set up. So all you have to do is just print this out with if you have a printer at your home, just print this out and cut it. You also make sure that you're going to put yourself some little tabs in here. That way that you'll be able to glue it together.